another week of maths. So we finished off looking at multiplication and division last week. You all did an amazing job. So please be really proud of yourselves. The consolidation stuff we did on Friday was absolutely awesome. So well done. Today we are moving on to fractions. Please don't be put off by the word fraction. They are not that bad. They are things that we use all the time when we're talking day to day. Think of cake or pizzas, okay? Think of food. Food helps with fractions. So, or if in Ava's case, cheese, okay? Think about those practical things when you say, oh, you're going to cut something in half. Think about what that means and what it looks like on a piece of paper. So we're going to talk about what fractions are. Then today we're just going to look at equivalent fractions, and that is the only work that you're doing today. So we're going to start easy and we will take our time. So fraction. I chose a very simple one first. We have a half. So one whole, cake or pizza, split into two equal parts, because this bottom number means it's that many equal parts. Okay, that is really important. So we have two equal parts. So our bottom number is our denominator. This is how many equal parts our object has been split into. Okay, could be a line, could be a pie, could be anything, but it has to be equal parts. So our denominator tells us we have two equal parts. Our numerator tells us we only have one of those two equal parts. Think of this line as being out of, okay? So we have 1 out of 2, 1 out of 2 equal parts, and that's all it is. That's all a fraction is. So as we start to look at equivalent fractions, it is just the numbers mean the same thing. So if I were to split my circle into 4 parts, we now have 4 equal parts. And we have 2 of those equal parts shaded. So now we have 2 out of 4. We have 4 parts, equal parts is our denominator, and we have 2 of the parts shaded, so our numerator is 2. Now this is the same, we still have the same amount as 1 half. So we have 1 and 2 if we had these split into halves, so if we got rid of that line again, or we put another line and we split it into 4. This amount has stayed the same. We haven't changed how much we've shaded, we've just changed how many parts the whole has been split into. It hasn't changed this amount. If you're eating half a cake, quite a lot I know, if you're eating half a cake and you cut your half into an extra piece, it doesn't change the amount that you've eaten, it just says that you've eaten it in smaller bites. And that's all this has done. It has changed our 2/4 into a half, or a half into 2/4, because we've cut it up again. Now, when we look at these numbers, when we're looking at equivalent fractions, the relationship between these numbers is always the same. So we're going to look at that in a little bit more detail. So let's get rid of these bits without knocking my board over. So we had 1 half and 2/4. Oh no, nothing like technical glitches. Right, sorry. 1 half and 2/4. So 1 half equals 2/4. We've already said from our diagram, sorry, not as accurate as the first one, that if we had 2/4 shaded, it is the same as 1 half being shaded. Yeah, so our numerator and our denominator are different, but the amount is still exactly the same. That is why they are equivalent. So, what I mentioned a second ago, before my board nearly fell down, was the relationship between these numbers is exactly the same. So, whatever you do to your top, you must do to the bottom. And that makes it equivalent because you're doing the exact same to both numbers. So for this one, to get from 1 to 2, we have timesed it by 2. And to get from 2 to 4, we have again timesed it by 2. 2 times 2 is 4, 1 times 2 is 2. So we have done the same thing to the top and the bottom. And that is as complicated as it gets. That is it for equivalent fractions. So we're going to look at a few examples. Now, your work today is going to, at least at the start, focus on bars that have been split up. Now, if we were in class, I would have printed a fraction wall, but we're not. So, imagine they're equal. In your first couple of questions today, you'll be working out how, so this one's split into 2 halves, and this one has been split into 6 equal parts. Yeah? So it's 6 equal parts, and if we shaded this, so this is our half. But if we shade in the same amount for our 6ths, so that's 1/6, 2/6, and 3/6, 3/6 is the same as 1/2. Can we see here the exact same amount is shaded in, same amount is not shaded, but this one has just been cut into extra pieces. Imagine it as a bar of chocolate. So you have half there and 6 there, but you have 3 of them to make up to 1/2. And then, as we said a moment ago, 1/2 equals 3/6. And we can check that by again checking that we have done the same to our top and the same to our bottom. So here and here. How have we got from 2 to 6? Well, to get to 6, we have 2, 4, 6. We have timesed 2 by 3. And to get from 1 to 3, we have also timesed it by 3. So when you're looking at equivalent fractions, the amount is exactly the same. They are just split up into more or less parts. If you were going the other way, so going from 3/6 to 1/2, the other way is it would have been divided by 3. But again, same to the top and the bottom. So hopefully that will be quite straightforward. Think about how many parts you have. Think about if you can get from there to there. Okay? So, what we're going to have a quick look at is some examples of what you're going to be doing today. So, some of your questions are going to be written like this. So you have to work out what the equivalent fraction is. So we'll start with the top one. So we have got 1/8. So all that means is 1 out of 8 pieces. So if we had our cake split into 8 pieces and we only have 1, okay, 1 out of 8. We're now going to have cut that into 24 pieces. I can't draw that very well, so I'm not going to. But the same thing applies. It's still that same amount of cake, just split into lots of other smaller pieces. So we need to look, how does our number 8 get to 24? This is where we need to practice our times tables. So we have 8, 16, 24. So 3 8s make 24. So we have timesed by 3. So now we need to do the same to the top. We need to times this one by 3 as well. So 1 times 3 equals 3. So they are our equivalent fractions for the first one. For the second one, 2/5. Now you might choose to draw them as bars, which is the first question that you will do today. So there's your fifths, and you have 2 of them coloured in, and then split those down again. Or how many tenths are going to make the same as your 2/5? So you'd have 1, 2, 3, 4. So checking here again. And it's really important, guys, if you are drawing bar diagrams to help you, they must be exactly the same size. Otherwise it doesn't work. So to get from 5 to 10, we times by 2. 5 times 2 equals 10. And to get from 2 to 4, we're timesing by 2 as well. Same to the top and the bottom. Last one. This time, we are going to look at making it smaller. We're looking at how we get from 6 to 2. So to get from 6 to 2, again, knowing our 3 times table, we're using the inverse and we're dividing. And that means we're doing the same up here. So 3 divided by 1. And again, you could check that by drawing bars or by drawing some other shape that you can do. You can split things in equally. So you'd have 1/2 there, and then 1, 2, 3, 6 there, showing that they are exactly the same. They are equivalent fractions. So I hope that that is enough. That is your fluency for today. And then there is just one reasoning question, which we're going to talk through an example of now. And then I'll let you get on. So, if, I think the question in the test is Ron, but so we'll go with Rob. Rob thinks that 1/3 is equivalent to 4/8. And you're going to be asked to explain if he is correct. Now, if we think of our 3 times table, I'll write it down in pink. We have 3, 6, 9, 12. We can't get to 8 in our 3 times table. So let's think about if we draw it. So let's draw our bar diagrams. Oh, a bit dodgy. So we'll have, split this into thirds. So we have, this is our 1/3 here, and this is another third, and this is another third. So we have our 1/3. Now, if we split this one equally into 8ths, it doesn't quite fit. So we have 1/8, 2/8, 3/8, 4/8. 4/8 would be about here. So that doesn't equal 1/3. So now we can think, well, it doesn't work that we can't do the same to the top and the bottom, because to get to here, we would have to times by 4. But if we times by 4 here, we would have 4/12. So 4/12 is equivalent to 1/3, not 4/8. So you would say Rob is wrong because 1/3 is equivalent to 4/12, not 4/8. And you could maybe show it on a bar diagram or some other diagram that helps you anyway. So I hope that's okay. From tomorrow, I will start running sort of help yourself workshops for maths. So I'm probably going to do that twice this week to get us up and running with fractions. So if you do have any questions, we can talk through some things live, face to face, as long as my computer is back working by tomorrow morning. And we'll go from there. So I hope that is relatively straightforward. Please don't be scared of fractions, okay? They are just 1 out of 3, 4 out of 8. You can understand that, you can do that, and I know you can all do it. So do your best, be awesome, and I can't wait to see your work.